Okay guys, it's me again. We're going to talk about the Coriolis effect. This is in your book. It shows you if you were going to fire a missile, we'll do it this side. If you're going to fire a missile from the equator, say northward, missiles go really fast, a lot faster than people can run. So it would have a path that bends to the east. That's because the Earth is rotating. The missile, when it was first launched, was rotating with the Earth, and so its path is going to bend towards the east. We kind of had some confusion on this. There's a question on your what did we learn questions, on your own questions that alluded to this. If you were shooting a missile from Southern California to Canada, which direction would you need to shoot it? Well, let's talk about that. I'm going to go up here. We're going to talk about the definition. Coriolis effect is the way in which the rotation of the Earth bends the path of winds, sea currents, and objects flying through different latitudes. Okay, so the Coriolis effect is basically the effect that the rotation of the Earth has on those things that are not necessarily directly attached to the Earth. Let's go over here. I've drawn a picture here for you. Might seem silly. This is a merry-go-round. I know it may not a merry-go-round. Yeah, a merry-go-round. It may not look like one, but it is. And there's a person on there holding a ball. And there's a person off of the merry-go-round that's holding a mitt. And they're playing catch. Now, one thing that we need to look at is this person is traveling in a circle. Okay? Just like on Earth, whenever we travel, we are traveling in a circle. The closer you are to the equator, the faster you travel. Just like whenever we linked arms in class and I had you guys go around in a circle, the person that was on the end had to move faster than the person that was in the center. The Earth is the exact same way. The poles do not have to rotate as quickly as the equator where it's larger, and so the Earth is actually moving faster at the equator than it is at the poles. Okay? So let's get back to our person. This little guy here is on the merry-go-round and he is spinning. If he was to throw his ball and he wanted to throw it and get it in this person's mitt, he's going to throw it straight. Okay? He's not going to throw it curveball. He's not going to throw whatever other kind of ball. He's going to try to throw a straight ball. Unfortunately, what's going to happen though, because this ball was moving with this guy whenever he was moving in this direction, his ball is going to veer off. Okay? Just like our missile does. And if you go outside, find a merry-go-round and try to throw your ball straight, you're going to find that your ball is actually going to go that direction. That's because it's moving. It's moving with you. Okay? And so it's going to continue to move in that direction. But if he wants that person to catch that ball, instead of throwing it straight, he's actually going to have to throw it kind of back this direction. Okay? And what will happen is the compensation will cause it to go into that person's hand. This is the same question you had in your book. It asked you about firing a missile from a place in Southern California to Canada. Which direction would you shoot it? Well, you'd want to shoot it northwest. And that's because the natural way that it would lean would be towards the east because it's already rotating. It's already rotating to the east. So it has a tendency to go that direction. Hope this makes sense. See you next time.